Here's a plot of natural log of r. So this is ln of r versus time. Is this zero order, first order, or second order? Natural log, first order. Okay, the natural log plot is linear, it's first order. What's the slope here equal to? Negative k, right? So how do you estimate negative k from the graph shown? Let's calculate our slope. How do we calculate our slope? Rise over run, right? Okay, let's look at our numbers here. By how much did it drop as you go from 0 to 2? So our run is 2, right? 2 minutes. It went from, what's that number right there? That's negative 1. So 0, negative 0.2, 0.4, 0.6, 0.8. So that's about negative 0.7. Okay? And so this is negative. And what is this number right here? This is negative 4, and that's negative 5. So 4.2, 4.4, 4.6, 4.8. So that's about negative 4.7, right? So negative 4.7 minus negative 0.7 divided by 2 minutes minus 0, right? That's your slope. And what would that number be? Negative 4.7 minus negative 0.7 is how much? Negative 4.0. Okay. And what's the unit for the numerator? What's the unit for concentration of R? Moles per liter, right? So, uh, think of it this way. Our numerator would be natural log of R at point number 2 minus natural log of R at point number 1, right? You pick 2 points. So let's call this point number 2 and point number 1. This is like y2 minus y1. That's your rise, correct? So what would be the unit for the difference of 2 logs of the same type of quantity? Remember your identity? Natural log of A minus natural log of B is equal to 1. The difference of 2 logs is equal to the log of the quotient, right? So that's the natural log of A over B. So this is going to be natural log of R2 over R1. So what's the unit for your numerator then? Concentration over concentration. So what's the unit for this thing? Unitless, right? A concentration term divided by a concentration term. So this is unitless. So anytime you plot logs, okay, and when you're calculating changes along that scale, the change along that scale will be unitless. So this is unitless up here, okay? So this number has no unit overall, okay? So the unit for this is so the unit for the whole thing for the slope is just negative 4 per minute, since the denominator has a unit of minutes. So that's your slope. So what's your rate constant for this? K would just be equal to negative of the slope, and your rate constant is always going to be a positive number. So negative of negative 4.0 per minute. Okay, so that's going to be equal to 4.0 per minute. Okay, as expected for a first order rate law, okay, for an overall first order reaction, the rate constant has just units of per unit time. Okay, what's the order of the reaction here? I'm plotting 1 over r versus time, and I'm getting a straight line. Second order, okay? And what's my slope equal to here? Slope is equal to k. Remember, for second order rate law, your reaction is what? Your equation is 1 equals 1 over r naught plus kt. Okay, so this is your x, that's your slope, that's your b, and that's your y. Alright, so how do we determine the rate constant from here? How do you determine the slope? Rise over run again, right? So let's pick 2 points. Let's pick this point right here. What's that number right there? So that's going to be our point number 2, and this is going to be our point number 1. So slope equals y2 is what? That looks like a 10 right there. Okay, so 10. And what's the unit for my numerator? Let's do that later. What's my y1? Looks like a 2, right? So 10 minus 2. And the unit for the numerator is what? It's 1 over r. R is moles per liter. So what's the unit for 1 over r? Reciprocal. So it's going to be liters per mole. Okay? And what's my denominator here? What's my run? This one's at 2 minutes minus 0 minutes. And so my unit for my denominator is minutes. Okay? So 10 minus 2 liters per mole over 2 minus 0 minutes. That should give me 5 divided by 2. I mean, not 5 divided by 2. 8 divided by 2. That's 4, right? So that's liters per mole per minute. Or per molarity per minute. Okay, so that would be the rate constant for that reaction.